Okay, so now we're going to do a math problem. And this is a tricky one. We're not sure why it's so tricky. There's got to be a way to put a drawing program. So let's just use Google Drawing. Right, drawings.google.com. And let's doodle, we'll call this a math problem. Let's call it recurrence. Relation question. Okay, and let's go into scribble mode. Scribble. And let's look at the problem. And I'll put a plus 1. Search for should find it because the problem had a and plus 1 in it. No, so I'll put a plus. Put math. Come on, show me the math. There's that math problem right there. So let's look on that day. So here it is, the American Mathematics Competition. So it was from 2022. And let's just see if we can see. That's definitely not it. So let's look for that day. What day was this on? Sunday. That makes sense. So let's find the problem. Well, there's a lot of things that happened Sunday because it was a chess tournament, but also I know I took a picture of the math problem. So let's look for that. Wow. Okay, so here's the math problem. Right? And we're just going to flip between these two. The sum, here it is, the sum of 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial all the way up to 2021 over 2022 factorial. Now, this is a fairly typical thing that math questions do, or mathematicians do, is they take a simple question and they make it complicated by just using big numbers, and a lot of them. So let's say we change this. Let's go over here and copy over the problem, which I believe I can just do that, and make this full screen, right? Let's make that full screen. Oh, and there's no way to get rid of this. Yes, and then the menu, how do you get rid of the menu? There's got to be a way to get rid of that too. But let's just do this. It is showing the question as, let me see if this works. Yes, so this says sum over 1 over 2 factorial can be expressed as a minus 1 over b factorial, where a and b are positive integers. What is a plus b? And it gives you some choices, right? So 1 over 2 factorial can be expressed as a plus or minus, let's double check. It's probably minus, yes, minus. So let's undo that. There's got to be an undo. There's the undo. Undo and say minus 1. Why is that 1 disappearing? Over b factorial. And don't tell me why the scribble looks ugly, but I'm not sure why. All right, so we'll try to make the numbers clearer. And then it goes all the way out to some crazy number like 2021 over, don't ask me why that disappears. It should not, 2022 factorial. But let's just make this simpler, right? Let's just say, and it says, what is a plus b? I want to make this thicker, so let me see if this, can I make the line thicker? Yes, so let's do it. What if it just said this? A over 2 factorial, 1 over 2 factorial, can be expressed as a minus 1 over b factorial, right? Of course it can be. This expression, you may not know it, but this expression will, in the limit as n goes to infinity, will go to 1, because this is 1/2, the next one is 1/6, oh no, 2/6, which is 1/3, and then the next and the next and the next. And so we can prove that too by mathematical induction, as they say. But this becomes a much simpler problem if you know that. And this is the trouble with these math problems, is that they're very simple if you know all the tricks, you know. So we know that a is 1, and this is a guess at this point, minus 1, they gave you that, gave us that, b factorial, right? In our case, we're ending right here. We already know that 1 minus 1/2, because that's what 2 factorial is. 2 factorial is 2, obviously, because it's 2 times 1, is equal to, and I'll use a different expression, 0.5, right? We know that. So if we answer this question ignoring all this complication, right? If we just do that, then it's 1 minus 1 over whatever this number is, 2 factorial is, and we already know that the answer is 0.5, right? So in this case, A is 1 and B is 2. So A plus B equals 1 plus 2, which is 3. But the question is not that. The question is, what if you expand it out to here? Well, if it's expanded to here or if it's expanded to here, it's the same. You just have to plug in the numbers. So it's 1 minus 1 over 2. It's the bottom one, right? Is equal to something. We don't know what that is. It's something less than 1, because obviously this is. And the answer to their question is, what is 1 plus 2, 0, 2, 2, and that's equal to 2, 0, 2, 3, right? So that's the answer to their question. Now that's not enough to prove this, but it is one of the choices right here. Oops, I guess you can't circle here, but It is one of the choices. So that's already a good thing. Now if we go back here, there's all kinds of assumptions that were done here, right? And I have to be careful. Next time I'll turn off this image. We have to prove a lot of this stuff. So let's create a new page. I think there's a way to create a new page. Can we make the page bigger? I guess what we could do is go here, and I think there's a Alt/ says it'll bring up a menu, and it doesn't. Oh, it did. Okay, so let's page. Yes, page setup. So let's just keep making the page bigger. Custom. And we'll make it inches. We'll say the page is, I guess this is height. So we'll make it 30 inches. Oh, that's not what we wanted. It stretches out. Why would it stretch that out? That's not good. So let's go back. Let's just copy this. Can we Control A and copy? And then can we clear? And can we change the page? I don't know what slash does, but Alt/ should give us the page setup. Let's do this again, and we'll custom, and we'll make this 30. Now we got a, so maybe we want to zoom in, I guess. That's the best it can do. Fit. I don't want it to fit. I want 100%. Good. So here we go. And I don't know. Yeah, I'm not zoomed, so that's good. So let's try to paste in what we did. And there it is. Good. But the issue with this is that we made all kinds of assumptions. That one, just looking at this thing and saying, oh, it's magical, it becomes one, is not true. I mean, it's not proven. So let's, and here's another thing that gets me about, and we're in zoom mode, so I don't want that. I want to go to 100%, and let's get out of this zoom mode and back into scribble mode, and here. So let's do this, and we can't just make these assumptions. So this is another thing that disturbs me about this, is obviously, see if I do that, that makes a mark. I don't want that. All right, so can I move it over here? No, that makes a mark. So how do you move? You have to move it this way. No, I guess you can't move it. Guess you have to move it this way. Okay. So let's just take this series and start writing it out. Partial sum. Let's just talk about a partial sum. Partial. And if somebody knows why the things disappear on the Chromebook, this is an old Chromebook, but it shouldn't disappear just because I didn't press this long enough or fast enough or whatever. So this is another thing that disturbs. Let's do partial sums. So we'll call this partial sum. Why does the p disappear? 1 is equal to 1 over 2 factorial, right? And then partial sum 2 is equal to 1 over 2 factorial, which is 1/2, plus 2 over 3 factorial, which is 6, and that equals 5/6, right? So then partial sum 3, and if anybody knows why that thing always disappears, look at that, parts of it disappear. Why is that? Is it trying to recognize something? I just want normal scribble. I don't want it doing any AI for me. Okay. is equal to 5/5 plus the next term, which is, I'm just going to write slower, see if that affects it. And I believe the next term is, this was 2 plus 3, and this was 3 factorial, and this is obviously 4 factorial, right? And if you do the dot, 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 the scribbles don't like if you just make just a little dot. I guess scribble mode. Oh, I think Scribble's trying to smooth things too. So partial sum is 5/6, and then the next one is 5/6 plus, going back, 3 over 4 factorial. So it's 3 over 4 factorial, which is equal to what? 5/6 plus 3 over a big number, which is 4 times 6, which is 24, so that means you have to multiply by 4 over here, right? And now, look what you got here, 23. Who knows why that happens? To get a better scribbler, over 24. And here's a disturbing thing is, they say, whoa, look at that. It's always 1 minus. So this is equal to the partial sum at PS1. Partial sum 1 is whatever it is, right? So let's say P partial sum, and this is just a guess, at n is equal to, try to make an n that's readable, n, and it just disappears beautifully. I'm going to go slower. What if I make the thickness even more? Partial sum at n is obviously n over n plus 1. Oh, this is not true. I'm sorry. That's not the partial sum. That's the term. But I'm getting the partial sum, and we see it's n plus 1 factorial minus 1, and then n minus 1 factorial. That's a guess. That is a guess. Just looking at this thing by induction, you see the pattern. It's the partial sum at this point was this. Then the partial sum at this point, at point 2, was this. Partial sum. And it just keeps going like that. Now this is a guess. Let's see if it's true. Right? What we have to do is prove that. And we do that by induction. Induction. And I'm not sure if you have to do all this for this problem. We already got the answer. Proof by induction, as they say. And I think that's wrong. Guess there's an eraser here somewhere. It's just 2 O's in proof. Good. So here we go. Case, let's see, base case, base. Since writing is so much torture, we'll put n equal 1. If n equals 0, it's going to cause an issue, I think. So let's just stick with n equal 1. 1. See if it's true. Where's the eraser here? Erase. gotta be a eraser. No, doesn't have erase. Where's erase? Huh. Gotta be a way to erase. Scribble, blah blah. Anyway, we won't. There ought to be a way to erase. Where did the menu go? Maybe this. And maybe under format, border lines, fill. How do you erase? Guess you have to be in a different mode to erase. It's crazy. I guess you have to select and delete. Yeah, maybe there is no erase mode. You kind of have to select and delete. Yeah, I guess that's what you do. Crazy, crazy, crazy. Okay. So I'll just put this N back. Right? Am I in the right thickness? Still looks terrible. Alright, so base case. Alright, so we say P partial sum 1, and we look and see, is it true that we know that the partial sum at 1 is 1/2, because that's 1 over 2 factorial. Is it equal to, question mark, question mark, you have to make big things here, you can't make little scribbles. Is it equal to 2 factorial, because I'm just plugging it into here, minus 1 over 2 factorial, and yes, 1/2 is equal to 1/2, check. Right? Now here's the assume step. I'm going to start, scripting doesn't work either. Assume that it's true for n equal k. Right? So P partial sum at k, we have to assume that it's equal. The partial sum at that point is exactly what our guess is. K plus, is it plus 1? Yes, k plus 1 factorial. And of course this can be written in a different way, but let's just keep it simple. Minus 1, this should be made clear that it goes all the way across. And then k plus 1 factorial, right? So we assume that, and now prove for n equal k plus 1, right? The next step. Well, what is P partial sum k plus 1? What is it? Well, we have to add. What do we add? The k plus 1th term, right? And the k plus 1th term looks a lot like this thing up at the top here. K plus 1 term. So every term k plus 1 term. So it's, we don't want to mess this up, so that's the partial sum, but it's also, we can say the term, let's just make it very, very clear. Term of 1 equals 1 over 2 factorial. So term of n, and this we know from the problem, the term at n is equal to n over n plus 1 factorial, right? That's the term of n, and we could double check that at any point. Let's just double check term of 2 over n plus 1 factorial. So let's just add that term here. So the next term is, if we look at our terms here, it's going to be n, so we put k plus 1. And what is and it's k plus 1 plus 1, so that's plus 2 factorial, right? Factorial, right? And now what we'll do is we'll put in our plus partial sum at k, because this is the term at k plus 1 plus this here. So it's k plus 1 factorial minus 1 over k plus 1 factorial. Now we just have to do the math. How do you add sums, fractions? You have to have a same denominator. So this needs to be multiplied by k plus 2 on both top and bottom. K plus 2, right? And then we can add them all. So let's see if we have enough room. It looks like we do. So this is a mess, but we can do it, right? Because k plus 2 times k plus 1 factorial is the same as k plus 2 factorial, right? By the definition of factorial, right? So all we have here is k plus, and I'm doing this a different way than maybe, and then on top it's k plus 1, let's make sure we don't make any mistakes here, plus, yes, we can do that. Oh, but wait a second, let's just make sure that we didn't, yeah, that has to be multiplied across, so we have to be very clear that that's there, right? So let's multiply that out. We get a k plus 2 factorial minus that quantity k plus 2, right? So what do we end up with? Obviously the k's disappear, and the minus 2 and the plus 1 become what? They become minus 1. Minus 1, right? And the other part is k plus 2 factorial divided by k plus 2 factorial, which can be written, if we divide everything by, is 1 minus 1 over k plus 2 factorial. And that's why it's always good to do all the math and then double check. Shouldn't be checking if it looks, yeah, and it actually is exactly right, because look, this one is easier to see, but this is how they write it in the problem, right? So we've proved it in the general step, because this PSK plus 1 plus 2, I believe. Let's just double, no, plus 1, I'm sorry. Yeah, it's easy to get, don't want to mess up the pluses, right? Should end up looking a lot like this. right? So look at this, PSK, that was the assumption, we assume, and so obviously PSK plus 1 must be K plus 2 factorial minus 1, because minus 1 doesn't depend on K, and then K plus 2, because it's K plus 1 plus 1, right, factorial. And that's exactly what we have here. So this is good. So that is proven by induction, right? So let's say that in the limit, the partial sum of n goes to infinity of 1 minus 1 over, how did we write it in the problem? They wrote it as, well, we wrote it because they don't make it clear, but we wrote it here as n plus 1 n, sorry, let me undo that, n plus 1, really doesn't matter because it's going to infinity anyway. What is 1, this is a question, minus 1 over infinity? That's 1. 1 over infinity is 0. So that proves our other point over here is, let me make this larger even still, make it that big. I don't know why it goes back defaults. It proves that our answer is correct. See, because I know that this full series, if it went on to infinity, would equal 1, right? And so this part is okay, and then the answer is this for this particular problem. But and there's a lot of hand waving here, and I especially don't like this guessing part. Oh, that looks a lot like blah blah blah. So that's the point, is let's make problems simpler. Thank you, peace out. How do I turn this off? There's got to be a way to turn this off. How do you turn the recording off? Okay, maybe I have to get out of full screen. Or maybe it's this one. Turn on phone hub. No. Oh, this one.